With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's solve the question. The question says, a wire of mass m length L can freely slide on a pair of parallel smooth horizontal rails placed in a vertical magnetic field B. The rails are connected by a capacitor C. The electric resistance of the rails and the wire is 0. If a constant force acts on the wire as shown in the figure, find the acceleration of the wire. So in this question, what is given to us? We are given two parallel rails and there is a capacitor connected here, and there is a wire which can slide on these two rails, and there is a constant force F which is being acted on the wire and is pulling wire towards right. So what is happening as wire is moving towards right, that area of this loop is increasing, so which means that flux is increasing. So there will be induced current in this magnetic loop, and direction of this induced current must be that such that it should oppose the change in magnetic flux. So induced magnetic field in the loop due to induced current will be opposite to the given magnetic field direction. So that magnetic field should be coming outside of the plane. So current has to flow in anti-clockwise direction. As we apply the right hand thumb rule, then we can see that induced magnetic field is coming outside of the plane, which is opposite to the given existing magnetic field. So electric current's direction will be such that, so let's suppose that electric current is flowing F. So now we can find that there will be magnetic field acting on this wire. So magnetic field force. So magnetic force is given by I L cross B, where L is the length of this wire and B is the existing magnetic field. So we have to find the current here. So first we need to find out the charge flowing in the circuit. So charge flowing in the circuit, there is a capacitor C is given. So we can say that charge flowing in the circuit will be CV, where V is the potential difference across this horizontal rod of mass m. So now we know that as flux is changing through this loop, so induced EMF across this wire is given by EMF, which is also be V. It is given by EBLV. So it is given by BLV, where V is the velocity of the wire, L is the length of the wire, and B is the magnetic field. So we can use this. So now we can find out the charge flowing in the loop. So we will get C multiplied by BLV. So now we can easily find out the current by differentiating it with respect to time. So current will be dq by, it is q, dq by dt. So now we have to differentiate it. So B is constant, L is constant, C is constant. It will come outside of the differentiation, and we will get, after differentiating, velocity with respect to time. So it will be acceleration of the wire. And now we need to balance the force equation. So what kind of force is acting on this wire? There will be magnetic force acting in the opposite direction, as we can easily find out using the right hand thumb rule, and there is a constant force F acting in the towards the right side. So net motion of the wire is towards right side. So suppose that wire is moving with the acceleration A towards right, so we need to find this acceleration. So now we need to balance the force equation. So what will happen is that F force, which is externally applied force, is acting towards right. Then we have to add magnetic force. So it will be in the opposite direction. So we have to put minus sign here. So we will write minus FB is equal to MA. Here we need to find out the acceleration value. So we just have to put the values here. So what is F value? It is capital F, which is given to us. It is constant. What is the magnetic force value? So we can calculate it using this formula. We have just calculated current value, which is B L C A multiplied by LB. We have taken here LB because there is angle which is between the wire and the magnetic field, which is 90 degree. So after solving this, we will get sine 90. So it gives us sine 90, which is equal to sine 90 degree. It is equal to 1. So we will just multiply it with L and B. So we will get B square L square C A. So this will be the magnetic force. So we can put it here. So B square L square C and A is equal to MA. So now we can easily calculate acceleration value from this equation. We will get A M plus B square L square C bracket equals to capital F. So after solving this equation, we will get our final answer. So our final answer is A is equal to F divided by M plus B square L square C. So this will be our final answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.